3, we are going to be combining exponents that have the same base. So we're going to rewind back a little bit to 7th grade. First off, we need to know that if we have a power, this whole thing is considered a power, okay? That has a base to an exponent. That whole unit is considered a power. And a base is the big number, the exponent is the small number. So looking at this example, this first example here, what is our base?
3.
3, that's the big number. This is really saying 3 times 3 times 3 times 3, right? I have 4 3's times 3 to the 5th. So now I have 5 more 3's. Times 3 times 3 times 3 times 3 times 3. That's what this is really saying. Which is 3 to the how many 3's? 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 3 to the 9. Okay? Okay, the next one. Well, what's my base of this next one?
2.
2. This is saying 2 squared times 2 to the 4th. That turns into 2 times 2, that's my 2 squared, times 2 to the 4th. 4 more. 1, 2, 3, 4, which is how many?
6.
1, 2, 3, 4, 5, 6, 2 to the 6th. Okay? The next one. What's my base? 4. Now notice they have to be same bases here. I see that a lot of you are finding the pattern already. Raise your hand if you know the pattern that's going on here. Oh, not too many. Okay. So about a third of us. This is 4 times 4 times 4 times another 3 4's. 4 times 4 times 4. Which is turns into 4 to the 1, 2, 3, 4, 5, 6. I want you to notice the new exponent and find the relationship between the original ones. And think pair share of what the rule would be. Try to write your own rule that I would make. The multiplication property of exponent tells us that if we have the same base, the same big number on the bottom, if we have the same base and we're multiplying, keyword is multiplying, not adding, then if we had a to the n times a to the m, that would equal a to the n plus m, just adding the exponents. That's our trick. Our trick here is all we need to do is add the exponents. So looking at this example here, I have x cubed times x to the 7th. Instead of expanding all that out, like we were doing on that first slide, I can just automatically go to this rule. Since they have the same base of x, and since they are being multiplied, this turns into x to the 3 plus 7, which is x to the 10. Okay? A to the 4th times a to the negative 3 turns into a to the 4 plus negative 3, which is a to the 1st, which is just a. That's utilizing the multiplication property. That's all we're going to do. Okay? So again, it has to be the same base. We cannot do it if it was like 3 squared plus 4 squared. First off, I do not have the same bases. Secondly, I am adding, not multiplying. We have to be multiplying in the center in order for us to use the multiplication property. So, do you think I would be able to use it for this? Yes or no? No, why?
No.
It's adding, not multiplying. Yep. What about?
Yes.
No.
Oh yeah.
No.
No.
Okay, give me a 1 if you think yes. Give me a 2 if you think no. It should be a 2 because they do not have the same base. Okay? They have to have the same base. All right, next slide. If there's coefficients, So if there's coefficients involved, all we do is multiply the coefficients and then add the exponents. That's the whole kit and caboodle right there. Multiply the coefficients and add the exponents. So with a coefficient example, what I would do, I see here I can just kind of pull the coefficients out. This would turn into 2 times 3 times x to the 4 times x squared. Now I wouldn't expect you to show your work like that. I'm just showing you really generic what this turns into. I can do this because multiplication is commutative, so I can flip things around, which turns into 6 times x to the 4 plus 2, since they are the same base, and I'm multiplying, which is 6 times x to the 6th power. Okay? Now I do this pretty fast when I'm doing my homework. I turn this right into 2 times 3 is 6, x to the 4 plus 2 is 6. That's how I do it in my homework. Okay? And I wouldn't expect you to do all of this. I do that to show you how it gets there. The why. Okay? All right. If there's no exponent, you always put a 1. You can choose to put that in your notes or not. We're just going to do some examples. If I had 3x times 4x to the 5th, I want you to simplify this, please. Simplifying this one, I always deal with my coefficients first. So I just go 3 times 4 is 12, and then I know I have a base of x. X to the 5 plus 1, which is 6. Because we have it, there's no exponent there's always that unspoken exponent of 1. Okay? Alright, I want you to simplify another one. And this is expanding quite a few skills here. Now I'm connecting this to previous day's stuff too. So fully. Okay. Now, simplifying this out. We got a lot of rules that we need to keep track of. This turns into 4 times 1, which is just 4. So that just stays there. It's not 5. You're not adding it. You only add exponents. X to the 4 minus 6, I'm at negative 2. Well, in our previous lesson, we learned that we should never have negative exponents. So that negative exponent needs to move. We make a spot for it to move. This turns into 4 over x squared. Okay? Connecting. I'm making a huge connections here.
I have that.
You didn't fully simplify it.
Yeah, like 4x. Do another one.
3x to the negative 6 times 5x. Simplify this. Alright, I see you guys getting more fluent with this. I'm loving it. 3 times 5 is 15. X to the negative 6 plus 1, I'm at negative 5. X to the negative 5 is going to be moved. This turns into 15 over x to the 5th. Done. All right. We have another concept to cover. If there's more than one variable, this is the last part of today. If there's more than one variable, all we do is combine only the shared bases. More than one variable. If there's more than one variable, all we're doing again is combining the shared bases. So if I want to simplify this, I see I have a base of x. This would turn into x to the 3 plus 1, right? When I don't have an exponent, I really have a 1. So x to the 4, y, and you know what, I'm going to be very generic here, so I'm going to just show you exactly how I got it. X to the 3 plus 1, y to the 4 plus 5, which turns into x to the 4, y to the 9. All right, I want you to try to do this next one. All right, this next example here, 2a cubed b to the fourth c to the fifth times 7a squared b to the sixth c squared turns into, now I'm going to multiply my coefficients. 2 times 7 is 14. I have students still adding them. Remember, you only add if it's exponents. And then I just start going with the bases that I'm given. Okay? A to the 3 plus 2, b to the 4 plus 6, c to the 5 plus 2, which is 14, a to the 5th, b to the 10th, c to the 7th. Okay? All right, I want you to write this using exponents. Negative 2 times negative 2 times negative 2.
What?
I want you to simplify that, please. It's just the same as an x, but instead of x, I have that parentheses. I see a lot of students writing answers that are totally wrong. I did not see one right answer. The closest to the right answer I got was this, and this is not right. Okay? Very close. What we would do, now imagine, this is me scaffolding again, taking what you know and connecting it to something new. If I had this, you would turn that into x to the 3 plus 4 plus a negative 4, which is x to the third power. Now instead of an x though, I have a negative 2. It's the same thing. I take the base to the sum of the exponents. Well, what's my base here, class? Negative 2 in parentheses, very important. Negative 2, it does count. Negative 2 to the 3 plus 4 minus 4, which is negative 2 cubed. Now, it wouldn't really count here. It would still be negative. But if I had a negative 2 to the fourth power, that's a big difference. Then it does not equal negative 2 to the fourth. Because this is saying take 2 to the fourth and then make it negative. This is saying negative 2 times negative 2 times negative 2 times negative 2. This is going to end up being positive. This is going to end up being negative. There's a huge difference. All right, that was fun. I stumped you guys. I stumped you. Let's try it. I'm going to try to do it again. Okay. All right. Simplify that, please. Okay, here's another one where I'm trying to stump. There's some kids still multiplying all of them. Do not do that. Just remember, we are going to do our base. What's your common base? My common base is that negative 3 in parentheses. To the 0 plus 2 minus 6, which is equal to negative 3 to the negative 4, which is, now this is a negative exponent, so I'm going to rewrite that as 1 over negative 3 to the 4. Okay? Alrighty, let me see if there's anything else. Okay. Not the numbered ones. Okay, let's do this. Negative 5, w to the 6th, y squared times 4, w to the negative 10, y to the 5th. I want you to simplify that one, please. When I simplify this expression, what I'm going to do is negative 5 times 4 turns into negative 20, w to the 6 minus 10, y to the 2 plus y. That turns into negative 20, w to the negative 4, y to the 7. I had a lot of students when I was going around and checking your answers. You put that -20 on the bottom.